Kia ora, Year 12 and 13. This is a video for Ethan from a Pure 3 paper in March 2021. It's a good partial fractions question, not too bad, and then some integration. And the main thing in the integration is not finding the integral, but using the log rules to clean it all up and show that the integral equals the natural log of 6. I'm going to do both parts in this, Ethan, even though I know you found the partial fractions part fine. So we're starting off with this function. We've got 5 over okay, so 5 over a times over 2x minus a times 3a minus x. We have to split that up into the usual two. It's going to be two linear factors in the two separate fractions. So I've got big A over 2x minus a and big B over 3a minus x. So doing a usual thing where we cross multiply, we get 5a is equal to big A times 3a minus x plus big B times 2x minus a. And we're going to substitute in values of x that zero out each of those terms. So we'll start with let x equal 3a, because that's going to be nice and easy in here. We've got 5a on the left-hand side is equal to big A times 0 plus big B times 2x's will be 6a minus a. So 5a is equal to 5a times b. Oh, and we know that a is a positive number. And so b must equal 1. So that was pretty good. And now we're going to do the same thing. So we need to zero out this term here, which means we need to make x 1/2 of a. And if you can't see that straight away, this is what I've got to do here. So 2x equals a, so x is equal to a over 2. That's the next substitution. So this time we get 5a is equal to a. So I'm working here now. 5a is equal to a times 3a minus 1/2 a plus b times 2a over 2 minus a. So that's a 0. So 5a is equal to 5 over 2 little a times a. Some of you will see that straight away, but the chances that you muck it up if you go too fast are quite high. So let's just go 10a is equal to 5a times a. So big A must equal 2. And that means that the function can be written as this. So f of x is equal to 2 over 2x minus, 2 over 2x minus a plus 1 over 3a minus x. And that's what we need to integrate in part B. So the limits are 2a and a. And the integrand is this thing here. So let's just go term by term, obviously. This is going to have a log pattern. The derivative of the denominator is 2, and that's sitting here in the numerator. So the first one is going to be the natural log of 2x minus a. Check it by differentiating. Do we get what we want? Well, we get 1 over 2x minus a times 2. So that's good. Now this one here is going to be also a log derivative. So it's going to be the natural log of 3a minus x. So when I differentiate this one, I'm going to get 1 over 3a minus x times -1, doing the chain rule on the inside function, but I don't want to take away, I want a plus. So we need to minus that to undo that. Hopefully by this stage in the year, that should be feeling pretty matter of fact. So that's where we get to. And now all the work to get to the natural log of 6 comes from substituting in and just chugging our way through combining log things. So we've got natural log of 2 lots of 2a, so 4a minus a. I can drop the absolute value signs because I know that a is positive. So 3a will also be positive in here, minus the natural log of 3a minus 2a, which is just a, minus the natural log of 2a minus a, minus the natural log of 3a minus a. Right, remember it's a show that question, so don't skip steps. So we've got the natural log of 3a minus the natural log of a minus the natural log of a minus the natural log of 2a. I don't know why I didn't just expand out that bracket straight away, but there you go. So this one here, we can combine this straight away to give me the natural log of 3a over a. And then here we've got plus the natural log of 2a minus the natural log of a. And in here, the a's simplify. So I've got the natural log of 3. And here I've got the natural log of 2a over a, which gives me the log of 3 plus the log of 2. And by our log rules, we get the natural log of 6. So there you go, Ethan. Hope that helped. Great to see you guys starting to send in questions like the 12 MCA class. So just keep on emailing them through, and I'll do them when I get time.